So in the previous video on the orbitals, we got the wire and found the standing waves. And so you could kind of see how electrons might be moving or found in around the atom. And so this sort of helps make a lot of sense, because if there's a positive nucleus and you've got, say, an oxygen atom there with like 2 in the inside shell and 6 on the outside, this is D's, not P's. And so say there's like P, X, Y, Z, and there's 2 that you can fit in each of those. So 2 in the, 2 in the first one, 2 in the 2s, and then you got 2 here. There's still space for 2 more electrons to go, and there's no reason why they couldn't fit in there, because the positive nucleus still has 3-dimensional space to fit another 2 electrons here, just to keep things simple. And so that's what happens. They just fill themselves up and they'll just grab 2 electrons. So oxygen will be found as an ion, as 2 minus. And so if it's not, it's called a radical, and it's highly reactive. We give it a big dot, and that will just potentially just react with anything, the first thing it hits. And so that is the logic behind why things form ions. And so we'll go into that in a little bit more detail when we do the in-depth, but we're first going to do just the quick overview. So the basic overview is, as you go down, of course, the ionic radii get larger. So as you go across, you've got the metals that form cations, and so they all decrease because they're in a lower shell. And then with your anions, they all increase because they gain electrons to get a larger shell. And then as you go down, it doesn't matter if it's anions or cations, because even though these are all lower shells, they are an extra lower shell, and even though these are full shells, they are still an extra shell as well. And so group trends, the ionic radii increase as you go down because they're an extra energy. They're a full electron extra energy shell or extra principal energy level, and across the cations get smaller, and the anions get larger. That's not enough. Let's do the deep dive. Okay, so as I said before, with the oxygen, this is the fluorine here. So relatively speaking, we're staying across the same period. So relatively speaking, it's starting to get really, really positive. And also the distance is starting to get small. And there's a 3-dimensional space there. So of course, an electron doesn't care about any rules. It just sees pos and neg, and there's a spot there. It's pos. This guy's neg. And so we're going to fit ourselves in there, and we're going to be 1 minus. All right. So hopefully that makes a lot of sense why the anions become negative. And then that'll be now a full shell. And so that'll jump up in size. All right, with the non-metals, the metals, there's the non-metals. With the metals, relatively speaking, this is not very positive. And as we did with atomic size, this is quite large. And so the electron is going to easily just drift off and be gone. And so that's why these guys have a full shell, but in the other direction. So this will be lithium 1+. Okay, so that's why a deep dive into why the metals go into cations and the non-metals go into anions. Okay, maybe a little bit too much of a deep dive. This is not, however. Okay, so again, you may need to talk about the specific, like to SPDF in a particular question if they mention a particular ion or atom or whatever. But this is the outline. Okay, so group trend, cations are smaller than the original atom due to the loss of electrons to have a full valence shell or a full principal energy level. Anions are larger due to their original size, due to their original atom size, larger than the original atom size due to a gain of electrons to have a full valence electron or a full principal energy level. So you can see the blue, they're all getting larger, and the pink, the ions have all gotten smaller. Okay, so this is going down. But both going down, both cations and anions are still getting larger, because even though they've all dropped a shell here, they're still getting 1 more extra shell. And even though they've filled up their shell, they're still gaining 1 extra shell as well. Okay, going into the detail that I may start skipping. Nuclear charge is larger but not effective due to increased electron shielding and because the distance is exponentially more significant than size with electrostatic forces, and valence electrons are also repelled by the inner electron shells. That's deep dive for you. All right, and hence and this is really important, the finishing off. Okay, hence valence electron shells are further away from the nucleus, less attracted to the nucleus, so the ionic radius increases for both cations and anions, very similar to atomic. Okay. Now, the finish off the deep dive for the periodic trend. So we've got two things going on. All right, we've got a drop, and then a further drop, and then we've got a jump, and then we've got a drop. Okay, so cations get smaller because they lose electrons to have a full valence shell that is of a lower principal energy level. All right, and then the cations decrease in size from left to right as the electron configurations are the same. That is unique. Don't mix that up. These actually all look the same. These ones here, that is, all right, electronically. But the nuclear charge is increasing, so the valence electrons are pulled closer to the nucleus. These guys have all gained the same shell, so the electron configurations for these are the same. It's just the nuclear charge is different, and same with these guys. Their electron configuration is the same, but the nuclear charge is different. So the next change is anions get larger because they gain electrons to have a full electron shell, these two blue bits. To gain a complete electron or a complete outer principal energy level. The anions, similar to atomic size, the anions then decrease from the left as the electron configuration is the same, but the nuclear charge is increasing, so the valence electrons are pulled closer to the nucleus. Okay, so again, you may need to be more specific than that as well, naming the specifics of it's the 2s or the 2p or whatever. Okay, so there you go.